Okay, we're going to talk about graphing a quadratic in the form of f of x equals ax squared. You've already worked through example 1 where we talked about the characteristics. A quadratic is in the form of y equals ax squared plus bx plus c. Okay? Y equals ax squared is the parent function, and we have done that many times where we are comparing other functions to the parent function. And I'm going to explain to you how we do the same thing with quadratics. Today we are just looking at the a value. When the absolute value of the a value is greater than 1, we have a vertical stretch, meaning the graph is getting narrower. Think about when you are stretching a rubber band. That rubber band gets skinnier, and that's what happens to a quadratic. When the absolute value of our a value is greater than 1, it is a vertical stretch and the graph is getting narrower. When the absolute value of a is less than 1, we have a vertical shrink. Okay, the graph is getting wider. Think about if you held a rubber band up and kind of pushed it down, that rubber band would be getting wider, okay, versus stretching it. When we have a negative a, we have a reflection. In the x-axis. It's hard to do this right with one hand. Okay, and you can see our parent function again is y equals ax squared. As our a value is greater than 1, right here, our graph is getting narrower. As our a value is less than 1, our graph is getting wider. When our a value is negative, its reflection in the x-axis, it's flipped. Okay, so it looks like an upside down U. So we could have a vertical stretch by a factor of any value greater than 1 and or a reflection. We could have a vertical shrink with a reflection in the x-axis. Okay, so that is the end goal. We'll read over the core concept and I will continue with the next example in another video.